Now we would like to call on stage Mr. Chang and Mr. Che from SELOCO. That will be our first presentation. Please, everyone.
Ladies and gentlemen, it's a great honor for me to talk to you about the internship experience of graduate student in our company. I'm Chang, a senior design engineer and associate development team in SELOCO Incorporation. In my development team, we have 2 intern students, as well as Korea University and Rafael of KAIST. For that matter, we are thanking very much for Graduate Embassy to have the opportunity to work with excellent student of graduate. Next. Yes. My company, SELOCO Incorporation, is a small, but very much high technology-oriented company. Next. The founder had a long background in this area of semiconductor design technology, government R&D institute like KIST, KD, and Entry. He had worked in Silicon Valley for 3.5 years. He then had founded 3 high technology companies in his business careers: Logic, Chip, and then SELOCO Incorporation. SELOCO Incorporation is the 3rd venture company. One of his main products, MyCAD, an electronic and IC design tool on MS Windows OS, has been on the market since 1990s. Its main users include Samsung, LG, Atri, and several small semiconductor companies in Korea. Panasonic, Canon, 3M, NXP, and several small US companies are its overseas customers. There are many universities in Korea, India, and China which teach electronic and IC designs with MyCAD for students. Next. Okay. SoC, as you may know, is the most complicated and advanced semiconductor device on the market. However, the SoCs also have very different levels of complexities, applications, and so on. SELOCO Incorporation is growing with ASIC and SoC business for revitalization in non-memory semiconductor business, which will be the foundation of all telecommunication products. Also, SELOCO Incorporation has a deep relationship with global main foundries. Before we go into a detail of the assignment and work, 2 interns has performed. Let me explain somewhat about the USN system sensors of SELOCO. This product is not complete, but the key functions are verified. Therefore, we are seeing several applications. Sensors providing vision to the existing sensors, sensing the weather of higher distance, light, temperature, and so on, and then transmitting the spot images. Image and composite sensor USN system to expand the sensing capability of the existing USN system for better convenient security tracking and surveillance, moving, sensing and imaging, distance and imaging, light and imaging, and so on. The sensor system consists of the gateway and sensor node. SG100F is Sensors USN SoC Solution Development Platform. In the FPGA, UC5000 is built in. UC5000 means a main controller IP. SG100F supports wired and wireless communications and provide USB connection and UART. And SG100F can use 8 kind sensors SN100 is sensor node is support 5 sensors: temperature and humidity, distance, light, PIR, and images, and built-in a single chip USN SoC. SN100 support wire and wireless communication. And this is our image USN SoC chip, UC5000CR2. Ours is somewhat a simple one with an 8-bit MCU, JPEG image compressor, some control function for CIS image signal input, and some memories. We'd like to add more IPs or functions like AD converter, flash memory, and communication functions are developed and so on in the future. And this single chip USN SoC solution will provide the reasonable price for image USN solution and will expand the existing network camera and LVOS system down to USN application. Next. Sensors is applied a security application where the sensor node detects a moving object or a person with a PIR sensor, and then the image is captured to be transferred to the client or the server. The transmission is done through 3 kinds of networking: Zigbee wireless, Wi-Fi wireless, and Ethernet wire. The Zigbee is rather slow to send image file since it has been dedicated for simple sensors value. A comparison of conventional PIR sensor on the left-hand side and sensor node SN100 on the right-hand side is shown. For the conventional PIR sensor, a secure step should come to the site to check the situation when moving or senses by the PIR sensors. For sensors SN100, it sends the site image to the security center. When moving or senses, the situation is checked at the monitor of the center. The sensor node can be placed in front of the door or entrance to check the visitor. It will remain without any activity. Once there is a moving is detected, it will send the image to the server or to the smartphone of the owner. This capability can be used in many other places like hall of the building, yard of a house, or front side of a house, and so on. It does not record the whole continuous period. It just sends the information to the owner when something happens. And this one shows some more complicated application of the sensor system. The person in need can be a senior citizen, a patient, a children, a disabled person, and so on. He may need some help from a helper, relatives, since he has so weak or so sick and hardly more by themselves. He has to have an emergency button to get help. In some cases, he may be left unconscious, moved by himself, and the central surveillance staff need to watch the person regularly. The system should have also a voice communication capability to exchange the status for the person. Similar situation can happen for some children left alone or to a pet in the house. This kind of system seems to be in a good demand since the number of elderly people is increasing in Korea and especially in Japan. A fit up-to-date parking management system is checking the entering car plate numbers to calculate the parking fee, to show the vacancy of the parking space and give some additional service to the visitor. And the modern parking system shows where the parking vacancy is available. By the way, the sensor system is checking the individual car plate number by assigning one SN100 sensor node at each parking lot. The sensor node should have a distance sensors so that an approaching object, in this case a car, can be detected. Then, the sensor node sends the car images separately to the central parking management system. The car plate numbers are recognized in the central server. The recognized car is logged in the parking management system. Next. The image and complex sensor USN system can be applied in many areas like security, surveillance, protection, management, convenience, amusement, in education, and in many others in the future. The application will expand when there is a more smart sensor node at the left coast. Okay, now the two interns are assigned to participate in a part of the development effort. ESBA in a hardware development assigned and Rafael in a software development project. ESBA is to develop a voice transmission and receiving function for the sensor system. And Rafael is assigned to develop an app for an Android phone to view the sensing value and the image of the sensors node of the sensors. We believe those assignments are to be very helpful for the intern student as well as for SELOCO to get a tangible outcome for its USN solution platform sensors. So far, ESBA and Rafael have been performing very well, achieving more than expected. Every Friday, the whole team, including the CEO of the company, Young Yu, reviews what was carried out during the week. Both ESBA and Rafael were not exposed to the assignment before. That is, they had to carry out a complete new problem to be solved. Adaptive differential voice code modulation, ADPCM voice codec implementation, and Android app development respectively. With the given topic, they have to study the needed materials by themselves. Of course, the advisors had provided some materials for them to study and to do some further research on the internet material. Let me show the example. Application where the sensor node would have a microphone, an image sensor, a speaker, and any other necessary sensor. The application would be used to take care of old people, disabled, sick people, children that need to stay at home alone and could have some problem. If the person needs something, it is just necessary to press a button and activate the communication system with the central or responsible take care of it. The central or the person can then listen what the emergency that is recorded by the person and also see using the image sensor the situation and take the necessary precautions. And to start the new project, the first thing that needed to be made is the project of the new hardware board. It's a challenge for him as a student that never made it before. And decide which component will be used, how will be the final circuit, make the necessary documentation and drawings a new experience. While making the board and after complete implementation, it is necessary to test it. Also, to take the treatment of the data, it is necessary to encode it into ADPCM. In order to do it, it is necessary to implement the ADPCM codec library with the encode and decode function, test it, and run in the board. After make sure that the new board works and the libraries are good enough comes the second part of the project, that is develop the real application that was delivered to him in the beginning of the internship. This is the SG100 app. He is proceeding this project based on the sensor board, but as can be seen, it does not have the audio hardware yet. This is main functionality of the ADPCM codec that was implemented. The encode function get a PCM value with 13 bits that was read from the PCM ADC codec and using the ADPCM. Encoder algorithm generated a 4-bit output value. This implementation reduced the final data amount more than 3 times in the decode algorithm to the opposite. This is the new hardware schematic circuit for the ADPCM system. This work is not in progress. That's all of the advanced work. And Raphael's work. Monitoring system consists of a sensor node, data center, and client device. A sensor node sensing the temperature and humidity, illumination, PIR, distance, and transmit the data using network. When the motion detected, sensor node capture image and transmit the data to the data center. The data center is received all the data and stored in database server. And the smartphone accesses the database server and check the stored data. That is the client view working in smartphone. And window 1 is the image view. You can see the captured image in the selected sensor node. To scroll the window, you can see the previous or next images. Window 2 is the temporal graph. In this window, you can see the selected sensor value. If you can touch the play button, the graph shows the sensor value regarding time scale. When you can touch the stop button, the graph stops. In this case, if you scroll the window, you can see the other sensor's value. And reset button shows the first data of sensor value. Each sensor node can have multiple sensors. Window 3 means the list of sensors that is embedded in the sensor node. Window 4 means the node selection. There's a number of sensor nodes in this system. In conclusion, it has been a very rewarding and encouraging period for us to work with Brazil intern students. We believe that they will also get an unforgettable work experience which will be helpful for their next career. SELOCO will continue its development of the USN SoC platform sensors, including the effort of ESPA and Raphael. SELOCO believes in the success of the Science Without Borders in our company as well as in whole Korea with the sponsorship of Brazil Embassy to Korea and the Brazil government. SELOCO sincerely wishes that the program will grow to a much more and useful platform for the coordination of young Brazil students and Korean counterparts. Thank you very much.